Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Okay, here I want to explain you more about the exercise of magnetisms I've already given to you in previous meeting in 12 ICC Boash Excellent Senior High School. Okay, for the first questions, we have two long straight parallel wires that are separated by a distance of 0.2 meters in air. Okay, wires P carries a current of 6 ampere and wires Q carries a current of 3 ampere, both flowing in opposite directions. Okay, I guess there is a mistake on the illustration. Okay, let's say that the left one is P wire and the right one is Q wire. And from the questions, we know that both flowing in opposite directions. Okay, so if we assume that the current in P wires is directed downward, yeah, this is I1, it's downward. So Q wires, the current will be directed upward. Yeah, so this is I2 actually. So this is still wrong, yeah, for the illustration. Okay, next, we have to write down the information or the data we got from questions. Okay, firstly, we have A, it's equal to 0.2 meters in air. So it's 2 times 10 power minus 1 meters. Yeah. Okay, next, for I1, it's equal to 6 ampere. I2 is 3 ampere. Okay, so um, let's see the questions. Calculate the magnitude of the force per unit length between two wires. Okay, for a point, I guess we can simply just use the F per L or magnitude of the force per unit length formula. It's equal to mu O times I1, I2 per 2 phi A. Okay, since we know that mu O is equal to 4 phi times 10 power minus 7, it because the wires are separated in air, yeah? So since it in air, so the mu O is this, yeah? So I1 is 6 and I2 is 3. Then it's 2 phi A and A is 2 times 10 power minus 1. Okay, so we can just do a common calculation. Yeah, we have 4 phi over 2 phi is 2, 6 over 3, 2 is 3, 3 times 3 is 9, 9 times 2 is 18. Yeah, okay, so we have 18 times then 10 power minus 7 divided by 10 power minus 1 is 10 power minus 6. So this is Newton per meters. Yeah, for the unit. Okay, this is actually the answer for the A point. Okay, for the B point, we have to determine the direction of the force acting on each wires and draw the direction clearly. Okay, firstly, we can redraw the wires. Yeah, we have these two wires, and this is P, this is Q. For the P, the current is directed downward. This is I1. I guess we can change the illustration. Okay, like this. This is I1. And for the I2 is directed upward. Okay, since we know that to determine the magnetic field induced by a current carrying wire, we can use the first right-hand rule. Yeah. Okay. For the P wires, we can induce a magnetic field at the Q wires. Let's say in here. Yeah. So using the first right-hand rule, yeah. So we will have the direction for the B or magnetic field it will be outward. Yeah, this is B1 or magnetic field that induced by I1. Okay, so for I2, it will be also outward. Yeah, we can use the sing the first right hand rule also to define the B2 or magnetic field induced by I2. Okay, so from this information, next we can use the second right hand rule. Okay, let's say that our thumb is directed downward and our index finger is directed outward. So we have for the force acting on the P wires, it will be directed leftward. Yeah. So this is FP or F1. Yeah. It's up to you. Yeah. Okay, next for the Q wires, it will be also directed rightward. Yeah. Or it will be outward. Yeah. Okay, so this is FQ. Okay, so what will happen between two wires? Okay, the wires will be bent like this. Okay, since there is a magnetic force that acting on each wires. Yeah, there is FP in here and FQ in here. Okay, that's all for the answer of number one. Okay, next for number two, we have a proton moves with a speed of 2 times 10 power 5 meter per second parallel to a long straight wire carrying a current of 10 ampere. The proton is at a perpendicular distance of 0.05 meter from the wires. Okay, first of all, I guess the illustrations again, yeah, there is a mistake information. Okay, so uh, it must be plus, yeah, since it's proton, not electron. Then the distance is not 10 centimeters. I guess this is 0.05 meter, yeah. So we have from the information that the speed is 2 times 10 power 5 meter per second. Then distance is 0.05 or 5 times 10 power minus 2 meters. Then I is equal to 10 ampere. Okay, I guess it's also wrong. Yeah, the I should be 10 ampere. Okay, I guess the questions is asking us about the magnitude force of and the magnitude of force acting on the proton. Yeah. Okay. Actually, to find the magnitude of force, we can just simply use the F is equal to Q V B sine theta formula. Q is proton charge. It's equal to 1.6 times 10 power minus 19 coulomb. Yeah, it's equal to the electron charge, but will be different for the sign. Yeah, if electron is minus and Q for the proton, it will be plus. Yeah, okay. The plus and minus will be influenced on the direction of the magnetic force itself. Yeah, later. Okay, first of all, we know the Q, we know also the V, and sine theta, it will be 1 since it's perpendicular or 90 degrees. So sine 90 degrees, it's equal to 1. Yeah, so we have F, Q, V, B, just this. Okay, but we still didn't get information about B. Yeah, so we have to find the B first, or magnetic force acting on the proton by a current carrying wire. So B it's equal to, sorry, mu O times I divided by 2 phi A. Okay, so B, it's equal to 4 phi times 10 power minus 7 times I, and I is 10, divided by 2 phi A is 5 times 10 power minus 2. Okay, 4 5 over 2 4, 2 5 is 2. Then 10 over 5 is 2 also. Then 10 power minus 7, it's over by 10 power minus 2. It will be 10 power minus 5. Yeah. So we have, sorry. Okay, so we have 2 times 2 is 4 times 10 power minus 5 Tesla. Yeah, this is the magnetic field acting on the proton. Okay, so we can just input the number to the F formula. Q is 1.6 times 10 power minus 19 times V. The V is 2 times 10 power 5. It's time by B, 4 times 10 power minus 5. Yeah, so we have 2 times 4 is 8, and 8 times 1.6, it's um okay, wait, we can just calculate it first. Yeah, so 1.6 times 8. Okay, 8 times 1 is 8. 8 times 6 is 4.8. Yeah, so we have, this is 12.8. Okay, so we have 12.8. It's time by, it will be removed, yeah, since it's the same. Okay, so we have 12.8 times 10 power minus 9 Newton. Yeah, so this is the force acting on the proton. Okay, any questions? If you have, maybe you can just try to ask me at the school. Okay, okay, next. For number 3, a long straight wire carries a current of 2.5 ampere. Find the magnetic field strength at a distance of 0.1 meter from the wire. Express your answer in Tesla. Okay, it's simple. Okay, firstly, we know that I is equal to 2.5 ampere. Then magnetic field strength, okay, at a distance, uh, okay, we have to find the magnetic field, right? Okay, and the distance is 0.1 meters, or 10 power minus 1 meter. Okay, so we have already know the I and A, and now we can just input the number to the formula for a long straight wires that carries a current. Yeah, so we have B equals mu O times I over 2 phi A. Okay, this one, it's 4 phi times 10 power minus 7 times I is 2.5. Then it's 2 phi times A is 10 power minus 1. It's 2. Then it's 10 power minus 6. Then 2 times 2.5 is 5. So we have 5 times 10 power minus 6 Tesla. That's all. This is for number 3. I guess it's easier than before. Yeah, the previous one. Okay, next for number 4. An electron moves with velocity v equals 3 times 10 power 6 J meter per seconds. I guess it's J hat, yeah? So it's a factor. Don't forget to um, remember again about the concept of factors. Okay. Okay. Through a uniform magnetic field, it's B equals 0.2 K hat Tesla. Okay. Calculate the magnetic force vector acting on the electron. Okay. Okay, firstly, because there is a factor in here, so we have to define, yeah, the answer by using a factor concept also. Okay, let's remember first about the concept of factors. Let's say that we have a 3D graph here. This is x-axis, y-axis, z-axis, and this is initial point, yeah, O. Okay, first of all, there is a term that is unit of vectors. The unit of vectors is um, a small unit of a vectors. Yeah, let's say that for the x-axis, this is I hat or I bold. Yeah, you can also write it as I bold. And for the upward, there is unit of vectors of y vectors or y-axis, that is j hat or j bold. Okay, next for the z, this is k hat. Yeah, okay. So next, to calculate the magnetic force vectors acting on the electron. Okay, first of all, we have to focus on determining the magnetic force first. Okay, so we can just simply use this formula, F equals Q phi B sine theta. Okay, since the case for these questions is asking about the particle charge, the charged particles that moves in the magnetic field. Okay. Okay, so for the electron itself, yeah, I've already told you before that Q is equal to 1.6 times 10 power minus 19. For V is 3 times 10 power 6, and B is 2 times 10 power minus 2. Yeah, this is in Tesla. And for sine theta, Um, okay, okay. Okay, for sine theta, we know that uh, the direction for V is J hat, so it means upward, yeah. J hat, it means upward. This is upward, and K hat, it's outward. Okay, so it will be form 90 degrees actually. Okay, so the sine theta, it will be just 1, so we don't need to write it to the formula. Okay, so we have just this form, so we can just calculate, the common calculation. 3 times 2 is 6. 6 times 1.6 is I guess 9 comma 6. Is that yeah, I guess it's right. Yeah. Okay, next. 6 subtracted by 2 is 4. 4 subtracting the minus 19, it will be minus 10 minus 15. Okay, in Newton. This is F. Okay, but the answer isn't enough, yeah, because we have to define the direction of the vector itself. Okay, first of all, we can make an illustration first that there is a magnetic field in here. Let's say that this is the magnetic field. It outward. So the magnetic field should be formed like this. Yeah. Let's say that this is magnetic field or a space that influenced by magnetic force. Yeah. Okay, next, there is an electron here and it's moved upward. There's an electron like this. Yeah, it's moved upward. And this is B. Yeah. So we can use the right hand rule actually, but don't forget that this is electron. So if it's electron, so the direction of the magnetic force, it will be reversed. Okay, so if we use the second right hand rule, that we use the velocity of electron is uh, directed by our thumb, and for B, it's directed by our index finger. Okay, so we will have actually the force acting on the electron. It will be leftward. Yeah, why leftward? Okay, maybe if we use the proton, so it will be directed rightward. If we use electron, so the direction will be reverse. Yeah, from the second right hand rule, maybe you can get the information for the force. It's directed rightward, right? Okay, but because this is electron, so the case will be different. Yeah, because the case will be different, so the force will be directed leftward. Okay, so if it's directed leftward, so it means it has direction minus I hat. Yeah, direction, it's minus I hat. So the answer for F is equal to 9.6 times 10 power minus 15. It's minus I. Sorry, it's not J. It's I. It's I hat Newton. Oh, it's really um it's a bit fun, yeah. I hat Newton. Okay, that is the answer for number 4. Okay, next for number 5, but I want to charge my laptop first. Please wait. Okay, guys, let's continue to our last number. And I guess it's still easy, yeah, if we compare it to the first and second number. Okay, a straight conductor of length. Okay, there is a length in here. L is equal to 0.8 meters, carrying a current of 3 ampere. So I is 3 ampere, is placed at an angle. So theta is equal to 90 degrees to a uniform magnetic field of strength. So B it's equal to 0.4 Tesla. And we have to find the magnitude of the force experienced by the conductor. Okay, it's simple, as I have said before, that F it's equal to I L cross B, then it's cross product. So we have I L B sine theta. Okay, I is 3 ampere, then L is 8 times 10 power minus 1. B is 4 times 10 power minus 1. Then sine theta is sine 90 degrees. Yeah. So we have 3 times 8 is 24. 24 times 4 is um, 96. Then it's for the 10, it will be 10 power minus 2. Sin sine 90 is equal to 1. Yeah, so we have 0.96 Newton. Yeah, for the force acting on the the magnitude of force experienced by the conductor. Okay, if you have any questions, you can just ask me. Yeah, as I already said before. Okay, by the way, I guess I have to remind you about uh, the the difference between proton and electrons when they moves in the magnetic field. Yeah. So to simplify your understanding or to understand easier about the concept, maybe for the proton, we can just use the second right hand rule, yeah, for finding the direction of force, the magnetic force induced by the current and magnetic field. Okay, so we can use for the proton, we can just use uh, the right hand rule, the second right hand rule. But for the electron, since the direction is reverse, so we just use um, the second left hand rule, I guess. Yeah, I guess there is no left hand rule, but yeah, just assume that there's left hand rule and the direction is the same. Yeah, for thumb, it represents the current, and index finger, it represents the the magnetic field, and middle finger, it represents the force of the magnetic force. Yeah, sorry. Okay, so the electron will be directed reverse. Yeah. Okay, that's all I guess for me. I hope it can be beneficial for you to prepare you more about the STS. Yeah, in I guess in Friday maybe. Okay, see you everyone. Thank you for watching this video. Assalamualaikum warahmatullahi wabarakatuh.